Okay. Hello and welcome to Module 3, Lesson 10 for 8th grade math. Today we are going to start the informal proof of the AA criterion for similarity. And we'll talk about what AA stands for in a few minutes here. And it's not Alcoholics Anonymous. It is something totally different in math. But we'll talk about that in a second. So we're going to begin with exercise 1 on page 51 of the Module 3 packet. And exercise 1 says, use a protractor to draw a pair of triangles with two pairs of equal angles. And I did this ahead of time because for the sake of time here on the video. So I chose the two angles of mine to be 30 degrees and 60 degrees. So I drew this first triangle here and I made this a 30-degree angle and I made this a 60-degree angle, and then I drew a smaller triangle and I just kind of flipped things around here with my angles. So here's my 60-degree and here's my 30-degree. Now, what we want to do here now is measure the lengths of the sides and verify that the lengths of their corresponding sides are equal in ratio. So before I do that, to make sure I'm measuring the same side with the corresponding side, I'm going to label each of these. So we're going to make this A, B, and C. And we want to make sure that those corresponding sides, or angles, I'm sorry, are labeled over here. So this is going to be A. This will be B near the 60 degree and C will be near the 30. Okay, so if you measure these, if you take a ruler and you measure these to the nearest centimeter like this, we'll go ahead and do this. So we're going to say 4 centimeters here. This right here is about 5.5 centimeters. And our hypotenuse on here is approximately we'll say 6.8 centimeters. I'm going to remeasure the 5.5 because I did that quickly and I want to make sure. Okay, yep. And let's do this on my smaller version here. And if we measure, we have about 1.5 here. And we have about 2 centimeters here. And then my third side, my hypotenuse is about, let's say about 2.5 centimeters. And we want to verify that they're in ratio. What we're going to do is we're going to take the lengths and we're going to set them up in a ratio or a fraction form. So we'll start with AB. So the ratio of AB to AB, we're going to say, is 1.5 here compared to 4 here. And so we'll do our next side. So A to C for me is 5. Oh, nope, sorry. We got to start with a smaller one. A to C is 2 compared to 5.5. And then the last one, my hypotenuse, is going to be 2.5 here compared to 6.8. And we want to divide this out and see what our ratio is here. So 1.5 divided by 4 gives us 0.375. 2 divided by 5.5 is 0.36. We're going to round that 0.367. And 2.5 divided by 6.8 is 0.368 about. Okay, you'll notice that these are very, 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 very close. And had I been completely accurate in my measuring and in my drawing, these should have come out all the same. The same ratio, the same decimal here. And the reason is because if I give you if there are two angles that are the same in two triangles, that actually guarantees similarity. If you take a protractor and you measure your last angle that's not given, you'll see that on the big one, it's 90 degrees. And on the small one, if you measure it here also, and I'll take a smaller protractor so you can see, on here, this one also, if you extend it, ends up being 90 degrees as well. And there's a reason for that. It should end up that way because if you take a look at that, there was only one choice. If you did 30 plus 60, you get 90 degrees. Well, we know there's 180 in every triangle, so 180 minus 90 would result in 90 degrees. That's the only choice for this last one. So all three angles have to be the same, which means that these are going to be similar triangles. And that brings us back to my original thought here, and that is of AA. AA theorem. AA in math actually stands for angle-angle. And what angle-angle states is that if you, not angles, angle-angle, triangle, theorem of similarity. What it is saying is that if you have any two angles given of a triangle that are the same as any two other angles in a triangle, you can guarantee that those two triangles are similar. And that's a shortcut that we use so that we don't have to measure every single side and every single angle every single time. Okay, so that's building up what we need to know. We're going to skip number 2 for time. And I'm going to show you some examples of some homework type questions that you're going to see with regards to angle-angle triangle theorem of similarity. So on the next page, page 52, we've got our first example here. And they have two triangles already drawn. And in the two triangles, there are some angle measures. So A is 31 degrees, A prime is 31 degrees, B is 103 degrees, B prime is 103 degrees. So obviously these two triangles are not congruent. One is obviously larger than the other. The question is, are the triangles similar? And the answer is yes. And that's because there are at least two congruent angles. Okay? And we just showed why that works before. We can use the AA theorem here. And the reason that it works, again, is because if you add 103 and 31, 103 plus 31, you get 134 degrees. 180 now for the entire triangle minus 134 gives us 46 degrees. So that's what this one has to be, is 46 degrees. Well, this is the same exact scenario here. So this one has to be 46 degrees as well. That means these two triangles have to be similar. Okay? If you move on, take a look at the next one. You have an identical triangle here. So 31 degrees, 103 degrees. We already did the work. We know this is 46 degrees. Next to it now, you have a match for A, 31 degrees and 31 degrees. But B now is different, 103 and 85 degrees. And we did the workout. We know the last angle is 46 here. So 103 doesn't match 85, neither does 46. So these are not similar because only one angle is congruent. Okay. Last but not least, the last type of problem you might see with our angle-angle congruent or similarity theorem is one that looks like this. So number 5 now, are these two triangles similar? So it gives you that A is 72 degrees and A prime is 72 degrees. So there's one match. It does not give you B, but it gives you B prime at 60. It gives you C is 48, but not C prime. So to figure out if you have two angles that are the same, you're going to have to figure out either angle B to match B prime or angle C prime to match C. And it doesn't matter which one you do. So I'm going to go with my originals here to figure out B. So I'm going to add 48 plus 72. So we get 120 degrees. And so I'm going to take 180 now for the entire triangle minus my 120, and I get 60 degrees. So B is 60 degrees here. So now I have a match of A with A prime of 72, and I also have a match of B with B prime. I have two matching angles. Therefore, are the triangles similar? Yes, they are, because there are at least two congruent angles once again. And that's the angle-angle theorem that we've been using. Oops, didn't know you couldn't see that. Okay, and if you were to do the workout 72 plus 60 just to show you, if you add those up, you get 132. And then if you do 180, minus 132, you will, in fact, get 48 degrees, which is angle C, and that matches, or angle C prime, and that it matches angle C. Okay, that's it for today. Hopefully these concepts are sinking in here. If not, please make sure you come and see me either before school or at lunch